Welcome to This Explainer. Today, we're diving into something super fascinating, a complete 60-hour programming lab syllabus for C programming. But we're not just staring at a dry list of classroom hours, right? We're actually looking at the blueprint of how a programmer's brain gets built from the absolute ground up. We're talking everything from basic logic all the way to complex memory management. The course introduction hits the nail right on the head with this idea. Knowledge of problem-solving and programming concepts is essential for those who develop applications for users. And honestly, that perfectly captures the stakes here. Programming is definitely not just about memorizing syntax or blindly typing out code. It's about systematically solving real-world problems for actual human beings. So here's our roadmap for today. We'll trace this entire 60-hour progression, moving through the course blueprint, foundations and logic, functions and arrays, pointers and structures, and wrapping up with assessments and outcomes. Let's get right into it.
Section 1. The Course Blueprint. Engineering the Future.
Okay, before we start laying down the digital bricks, we really need to understand the big picture targets driving this 2-credit course. The curriculum is explicitly anchored in Sustainable Development Goal 4, which is quality education, and Program Outcome 11, lifelong learning. So what does this actually mean for you? It means the goal isn't just to teach you C programming and just send you on your way. The aim is to instill lifelong learning skills so you can adapt as technology inevitably changes. You are, quite literally, learning how to learn. Section 2. Foundations and Logic. Mastering the hand tools. So in the first 2 modules, we pick up our basic hand tools to tackle algorithmic thinking. And problem solving here always starts with 3 absolutely crucial planning steps. First, develop an algorithm. Next, draw a flowchart. And finally, implement the C logic. You are required to design the logic and the visual architecture of your solution before you write a single line of C code. I mean, think about it. A physical builder wouldn't just start pouring concrete without a drawn schematic, right? The exact same rule applies here. And you'll immediately put these concepts to work through some really hands-on tasks. Tasks 1 and 2 have you calculating percentages and total marks using fundamental variables and arithmetic operators. Then, you step it up in Task 3 to determine a pass or fail based on minimum criteria. Task 4 gets even more granular, categorizing students as distinction or first class based on their percentages. And finally, Task 5 introduces iterative loops to process 5 students' data all at once. See how we're stacking these skills? We're moving really rapidly from a single calculation to actual batch processing. Now, a huge part of this syllabus is also dedicated to self-learning topics. So as part of your independent study, you'll need to contrast branching concepts. Specifically, you'll look at how a break statement stops a loop entirely, just completely ejects you from that block of code, while a continue statement simply skips the current iteration and keeps the loop running. It's a subtle nuance, for sure, but honestly, mixing these up is a total rite of passage for every beginner. Truly understanding these control structures is what separates a novice from a really solid logical problem solver. Section 3. Functions and Arrays, Upgrading to Power Tools. Moving into modules 3 and 4, we start scaling up our building capacity. Because instead of constantly rewriting your code every single time you need to evaluate a student, Task 7 teaches you to create reusable grading functions. You literally define the logic once, and then you just call it whenever you need it. Then Task 8 introduces arrays. Instead of juggling a dozen different messy variables for a classroom, you use a one-dimensional array to efficiently store and average the marks of an entire class in one unified block of memory. It's really all about efficiency and scaling up your data. But hey, we don't just deal with numbers, do we? That's where Task 9 brings in strings. You'll learn to handle text-based data using functions from the standard library. You'll be able to store student names, manipulate that text, and retrieve specific info based on name searches. Once you start doing this, your applications really start to feel a whole lot more like the real-world software we interact with every single day. Section 4. Pointers and Structures. Mastering the Heavy Machinery. All right, we've reached the boss level in Module 5. This is where you move beyond simple variables to handle complex data and memory directly. Enter the pointer. A pointer is simply a variable that stores the memory address of another variable. Now, I know pointers are famous for giving computer science students absolute nightmares, but they are fundamentally powerful tools. They grant you direct memory access, dynamic memory allocation, and incredibly efficient processing capabilities. You aren't just working with data anymore. You're working with the actual physical space inside the computer where that data lives. It's a total game changer. And all of your hard-earned skills culminate in Task 12. This is a serious project.
You'll combine structures, arrays, functions, and those scary pointers to build a fully functional, integrated, menu-driven student management application. We're talking record entry, display, and search functionalities, updating records, identifying the class topper, generating complete results, the whole shebang. This is the exact moment you transform from a student into a genuine software builder.
Section 5. Assessments and Outcomes. Proving your mastery. So, how does the apprentice actually prove their mastery? Well, the course uses a pretty strict 100-mark evaluation scheme. For the 50-mark in-semester assessment, the crucial thing to note is that half your grade heavily rewards practical, hands-on building. You literally get 30 marks just for executing the minimum 12 tasks we've been discussing. Then there's 15 marks for a practical test, which tests your logic building and error rectification on the spot, and 5 marks for your regularity and active participation. Then we have the end semester examination for the remaining 50 marks. And let me tell you, this isn't just a standard written multiple choice paper. This is where the pressure is really on. It's a practical and oral exam evaluated by both an internal and an external examiner. You earn 30 marks for task execution, where you have to code a unique, brand new task live on the spot. You get 5 marks for presenting your results and drawing logical inferences, and a massive 15 marks for an oral examination covering the entire syllabus, meaning you can't just write the code, you have to verbally defend your logic to an external expert. No pressure, right? Let's zoom out for a second and see how this all builds into the final picture. This rigorously structured grading scheme ensures you've systematically hit every single mark, from Course Outcome 1, which covers basic data types and operators, all the way to Course Outcome 5, covering structures, memory, and pointers. Every single task, every flowchart, and every line of code you write in this 60-hour lab is deliberately mapped back to make absolutely sure you master these fundamental concepts and learning objectives. Which brings us to our final thought for today. You now hold the blueprint. You've been trained on the hand tools, the power tools, and the heavy machinery of C programming. But, knowing how to use a hammer doesn't automatically mean you know what house to build. So, in an ever-evolving tech landscape, how will you use these foundational tools to build the future? Thank you so much for joining me in this explainer, and happy coding.